the cosine rule. The cosine rule is another way we could solve a non-right triangle. So we have a triangle, it's not a right triangle, you can solve with the cosine rule. Now, particularly these formulas right here are to help you find a side. So if you're missing a side, we're going to use one of these formulas. Now they're all very similar. They're actually all kind of equivalent. If you notice, that like in this case, the thing on the side here is what we're looking for. So we're looking for a squared, we need angle A. Looking for b squared, you need angle B. Looking for c squared, you need angle C. So that's the way it kind of works. Now, in the formula sheet for IB, they actually only give you one of them. That would be this one right here. So that's the only formula we're going to give to you because these are all equivalent. So if you have this one, you could find this one. Because look what happened. If you need to find side B and all they have is this formula, well, you make side B, you make b squared here. That makes this angle B, and then the other two things are A and C. Like right here, right? On this one, you have A and A. Then the other two are B and C. You have C and C. The other two things are A and B. Like it doesn't matter. A and B don't matter. It doesn't matter which one goes first or second. It doesn't matter at all. Only thing that matters, the one you're looking for, is also the angle. The other two are everything else. So that's the way it goes. Note, if you notice this, right? If A is a 90-degree angle, or if the angle is a 90-degree angle, then cosine of that angle is 0, and this all goes away, and you just have the Pythagorean theorem. So let's do an example. So one way we solve this is if we want to find the missing side. So if you're given two sides and an included angle, the cosine rule can be used to find the length of the third side. So here we want to find the length of BC. So that'll be side A. Now again, the formula they give us in the formula sheet would be the c squared one. Now you could, since we're looking for side A, you could change that to one with A in it. So that makes that A squared. It makes this cosine of A, and then everything else is just B and C. It doesn't matter which one comes first. So it goes like that. And all we gotta do is substitute stuff in there. So if this is side A, this is angle A. This is angle B, this is side B, and then side C. So you just plug it in. A squared is going to equal 13 squared plus 11 squared minus 2 times 11 times 13 times cosine of 42. Now, if you notice here, there's no variables at all. It's just all values. So we're just going to plug that into our calculator and not think twice about it. Let's go here. All right, so we're going to do 13 squared plus 11 squared, make sure we're in radians, minus, degrees, make sure we're in degrees, because we're doing degrees here, times 2 times 11 times 13 times cosine of 42. And then we get that, so that's what our a squared equals. So it's another one of those times where I'm going to round it here, but in my answer, when I actually do the next step, I'm going to leave the full answer in my calculator. So we're going to square root both sides. Select my full answer. So we're square rooting both sides. And then a equals 8.80. Just trying to do 36 figs centimeters. So there we go. It's a lot of cosines. That's how you use it to find a side. Now again, when you generally use it to find a side, then it's probably the easiest way because you just substitute that all in and simplify. Now, what if I give you all three sides? I want you to find an angle. Well, then we could rewrite that to be the angle formula. You just solve for the angle here. So like subtract this over, divide by this, and you get one of these formulas. Just like last time, I'm just going to give you one of them on the formula sheet, which is this one. No one to see in it. So it works the same way. Like if you're trying to find angle A, just make that an A. You make that an A, and everything else would be the other two, B and C. Doesn't matter which one's first. Only part that matters is whatever the angle you're looking for is, that's also when you're subtracting. Everything else is the same. Also, keep in mind that once we substitute the same, we're going to get cosine C equals something. How do you get rid of the cosine? You do cosine inverse to evaluate. So let's actually do one. In triangle ABC, AB is 7, BC is 5, and CA is 8. So let's draw the triangle. Again, I just draw a basic one. And label the sides. Angle A, angle B, angle C. That would make side B over here, side A over here, side C over here. AB is 7 centimeters, so this is 7. BC is 5, and CA is 8. We want to find the angle measurement of BCA, so BCA. So I want angle C. Oh, so we get to use the normal one in the formula sheet. Cosine C equals, you don't have to write down the formula, I'm doing it because I'm teaching. Minus C squared over 2AB. So I'm going to get cosine of C equals, now remember, A is opposite A, so A is 5. A and B don't really matter. B is 8. Here's the one that matters. Angle C gets to 7. Minus 7 squared, and then 2, 5, and 8. So we're just going to put that all into our calculator. Now, you want to watch how we put this in the calculator? Some people like to do the top first, and then the bottom, and then the bottom. That works. I'm going to use my fancy alpha fraction button, because the most common mistake is they don't put parentheses around the top. So if you're putting your calculator, either put parentheses around top and bottom, or do the top first, top, and then the bottom second to bottom separately, or put a fraction button up there. So 5 squared plus 8 squared. It's really easy to make a mistake if you're sloppy about this. Divided by 2 times 5 times 8. So I get 1/2. I'm going to do cosine of C equals 1/2. We'll take 1/2 inverse of 1/2 of both sides. And I don't need a calculator for that one. That is just 60 degrees. So there you go. C is 60 degrees. Now they also want to find the area. Now areas from a previous lesson. Area of a triangle is 1/2. So everyone knows 1/2 is that, but don't forget, if you don't have the height, the area is 1/2 AB sine C. Now the sine C, A and B and C don't mean a thing. It just means two sides and the included angle. So my angle is 60 degrees, which happens to be angle C, funny enough. But even if they were like non-labeled, right? If I had all this blank, not all that, I need that there. There we go. I would still go, okay, there's my angle I have, here's my side, and here's my side next to it. So two sides and the included angle. Only part that matters. So 1/2, 8 times 5 times sine of 60. So you put that on the calculator, do by hand, but let's go 0.5 times 8 times 5 times sine of 60. And we get 17.3, approximately 17.3 centimeters squared. Remember, we're doing areas, so areas always squared. Anyway, there's that one. Next one, find the measure of all angles of this triangle. So I do law of sines again. Sorry, law of cosines again. It doesn't matter where you start. General trick, I try to start with the largest angle, because all sines can't do big angles, but law of cosines can. Law of sines can't do obtuse angles, and law of cosines can do any angle. So I always start with the biggest angle first, and the biggest angle will be opposite the biggest side. So something like that. Also, that matches the formula they give us on the formula sheet, right? Cosine of C equals A squared plus B squared minus C squared over 2AB. So cosine of C equals, A would be here, B would be here. So 11 squared plus 12 squared minus 13 squared over 2 times 11 times 12. Use my calculator again. So we're going to do alpha y equals, get a fraction, make it easier. 11 squared plus 12 squared. Oops, it's an accent. Minus 13 squared. All over 2 times 11 times 12. And we get 4 over 11. So cosine of C equals 4 over 11. Then we're going to inverse cosine that. 68.7, roughly. So that's going to go here. Now I got to find another angle. So there's a couple ways we could do. We could do law of cosines again, but for another angle. But most people prefer, once they do law of cosines once, they prefer to do law of sines, because now you have a pair. So I have a pair. So now I could do law of cosines, law of sines. So we could do, let's see, 13 over sine of 68.7 equal, let's find angle A. With law of sines, I can do the opposite. I try to find the smallest angle first. So here's A, and that goes to side 11. So 11 over sine of A, cross multiply, 11 sine of A equals 13, mess that up, 13 sine of A equals 11 times sine of 68.7. We're going to divide by 13. I'm going to get sine of A equals whatever that equals. Use my calculator again. 11 times sine of 68.7. Now this time I'm not going to use my like the actual answer. I'm going to use 68.7 because that was like a final answer for one of our sides, our angles. So now from now on, since it's an actual answer they wanted, for now I'm just going to use that as my C. And then I'm going to divide that by 13. I get 0.788. Compared to this one where I'm going to write 0.788 here, but in my answer I'm actually going to do the full thing because it's not an official answer, right? I didn't like box it in. So let's get rid of the sign. So sine inverse of both sides. And then here, sine inverse of my answer is 52. Let's use 52. 52.0. Usually 36, so yeah, the 0.0. Well, right here we'll say 52. So I get that. Now they want me to find all angles. So if I want to find angle B, well, how do I do that? Well, it is a triangle, so if you add up all angles of a triangle, you get 180. So that's the easiest way to solve the last triangle is to do that. So we'll do that for this one. We're just going to do 180 minus 52 minus 68.7. Easiest way to find the remaining triangle all the time is just do 180 minus the rest of the angles. So 180 minus 52 minus 68.7. 59.3. There we go. So that's how you find all angles of a triangle if you're given all the sides. Law of cosines once, then you can do law of cosines again if you want, or law of sines like I did here. And then anytime you want to find the last angle, no matter what you do, is just subtract 1/8 from the other two angles. Two more real quick. Find the largest angle of a triangle with the sides 4, 7, and 9. And as he says here, right, the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. So I'm going to do a basic triangle. Ooh, that was a triangle. There's no sides listed, so it doesn't really matter. So we'll just do 7, 9, and 4. I want the largest angle. Largest angle will be opposite the largest side. So this would be 9 largest side, so that makes that this. Now remember the angle formula, that the formula she gives us is this one. Cosine of C equals A squared plus B squared minus C squared over 2AB. Since I'm looking for the largest angle, I'm just going to name the largest angle I'm looking for C. It makes that C. Right, all the rest of it doesn't matter. It's A and B, doesn't matter which one's which. So let's say cosine of C, so it could match the formula, equals 4 squared plus 7 squared minus 9 squared over 2 times 4 times 7. Put this all in our calculator. So 4 squared plus 7 squared minus 9 squared. Oh, I should have, whatever. I did that first. Now divided by 2 times 4. I have to use my fraction. But since I'm doing this way, make sure parentheses. So I get that decimal. So cosine of C equals negative 0.2857-ish. Again, that's not my final answer, so I'm going to leave that. I'm going to use that answer when I do cosine inverse of both sides. Cosine inverse of the thing I just got. So 106, 36 is probably about 107, since it's 100%, 100 degrees, over 100 degrees. So we'll do it 107, 36 figs. So about 107. And there we go. That's the answer to that one. Oh, mistake there. Just C, not cosine C. Should have done cosine inverse of both sides, which I did do. I just didn't write it. And right, your answer is just C, not cosine C. C is my answer. I got rid of the cosine. Okay, last one. Find the value of x. So it's a little tricky. So we have pretty much everything we need. We have all the sides and an angle included, which is all you need to find. Use any cosine formula. So what we're going to do is use any of the cosine formulas to set up an equation. So let's use the classic, which is C squared equals A squared plus B squared minus 2AB cosine of C. Now remember, C is the angle you're looking for, have. In this case, I have. So that makes that C, that makes that little c. A and B, I guess, it doesn't really matter. A and B. Let's substitute our values in. So we're going to get 5 squared. Remember, this is always the side, not the angle. The angle goes here. So 5 squared equals x squared plus 2x squared minus 2 times x times 2x times cosine of 60. Now, one way to solve this would just to put this into your calculator, y1, y2, and try to solve it like we've done many times before. Another way to solve it, I think this one's probably able to solve by hand. If we just simplify everything. So let's try that first, I guess. X squared plus this squares with both of them, so we get 4x minus 4x squared to get here. Oops, 4x squared. 4x squared here also. 2x times 2x is 4x squared. And then cosine of 60. Now, that has to do with unit circle. But I'll tell you right now, you can put in your calculator, just get 1/2. That's what that is. 1/2. And then we can simplify this. We had to do this first. I thought things were going to cancel out, but it's going to work out. So if I multiply these together first, I get 5x squared minus 2x squared, which will give me 25 equals 3x squared. Divide by 3. Not going to be pretty. And square root it. You would get plus and minus, but we can't have a side of a triangle be negative. So my answer is only going to be x equals square root of 25 over 3. That ugliness. Anyway, that's the lesson.